Okay, this video is on how to use the distributive property. Okay, here's some examples. We're going to go ahead and do these in your journal. Pause the video when needed so that you can keep up and get everything down in your journal. Okay, our first expression is actually a numerical expression. It has all numbers, and yes, normally if we used order of operations, we would add the 5 and the 8 together first because it is inside the parentheses. Then we would multiply it by the 3. But we're going to use the distributive property on it this time. Alright, so this is how we're using the distributive property. We know that we need 3 groups of the 5 plus 8. And we can break this down differently, and we can share or distribute the 3 to each term inside the parentheses. And that's what we're going to do. We're going to take the 3 and we're going to share or distribute it to the 5. We want 3 groups of 5. Well, when you distribute, you're multiplying. And 3 times 5 is 15. The second term, you're going to do the same thing, but we're going to add a step to it. Just like we did with integers, we need to make sure we know the sign of this 8. So we're going to circle it with the sign in front of it. And this tells us it's a positive 8. Now we can distribute the 3 to this positive 8. We want 3 groups of the positive 8, so that's 3 times 8, which is a positive 24. So we now have 15 plus 24. Since they're both numbers, we can simplify this again by adding 15 plus 24, which gives us 39. Okay, let's go to the right. We want 7 groups of negative 4z plus 3. So we're going to distribute the 7 by multiplying it by each term inside the parentheses. So our first term is negative 4z. When you're doing the multiplying, you're actually multiplying the 7 by the coefficient of the variable. So we're multiplying 7 times a negative 4, which is negative 28. And we don't know the value of z, so it's going to remain z. It's going to remain the variable. Now we're going to circle our second term, which is a positive 3, and we're going to distribute the 7 to our positive 3 by multiplying. And 7 times 3, or times a positive 3, is going to be a positive 21. So we have negative 28z plus 21. We cannot combine these two any further because we don't know the value of z, so we leave it as it is, negative 28z plus 21. When you're distributing, the goal is not to get a single numerical answer like we did over here. In our first example, we could do that because it was a numerical example. But when you're dealing with an algebraic example, you have that variable that has that unknown value. So you're not going to get one numerical answer because you don't know the value of z. This is as simplified as you can get it. Okay, let's try the next one. 9 times the group of 3d plus 8. So we're going to distribute the 9 to the 3d by multiplying, which means we're going to multiply 9 times the coefficient of the variable. So that's going to make 27 d's. We're going to circle our second term with its sign. It is a positive 8, so we're going to distribute the 9 to the positive 8, and 9 times 8 makes a positive 72. Again, we have the variable, so that we cannot simplify this any further. Our simplified expression would be 27d plus 72. The next example is a little different because we have a negative number out here. We're distributing a negative number. You still do the same thing. So we're going to distribute the negative 3 to the 6, so we multiply. And we know that a negative times a positive is a negative, so this is going to give us a negative 18. Circle your second term, and this is also a negative. So you're going to multiply the negative 3 with the negative coefficient. And a negative times a negative is a positive. So it's going to give you a positive 6f. The simplified expression, negative 18 plus 6f. Now, this example down here is a little bit different, and sometimes you're going to see this. And there's 2 ways to think of this. The first way to think of it is that when you don't have a number in front of it, you just have this negative sign. The negative really means the opposite, right? So we want the opposite of everything that's inside the parentheses. Another way to think about it is that this is really a -1 times the group of -4 minus 3n. So you could distribute the -1 to each term inside the parentheses. Either way, it gives you the same results. I'm going to go with this being the opposite. I want the opposite of every term. So my first term is -4. The opposite of a -4 is a +4. I'm still going to circle my second term so that I can clearly see the sign. It's a -3n. So the opposite of a -3n is a +3n. The simplified expression would be 4 plus 3n. And our last example. Now, this is not the correct way to write this with the number of groups behind the grouping. Really, this 2 should be in front of it, but sometimes you're going to see it written like this, and you still need to be able to simplify that. It doesn't change. You're still going to distribute this 2 to each term inside the parentheses. So my first term is an 8. So 2 times 8 is 16. I'm still going to circle my second term, which is going to show me that it is a +2y. So I distribute the 2 with this +2. I multiply it with the coefficient, and it's going to give me a +4y. Oops. Simplified expression is 16 plus 4y. So when you're doing your homework tonight, I expect to see the arrows showing me how you're distributing the number of groups. I expect to see the second term with its sign circled, and then you write your simplified answer. So go ahead and watch this PBS Math Club video, the Distributive Property Friendship Bracelets, and when you're done, you can start on your homework, which is the Distributive Property Worksheet by CUDA Software.